Hello, everyone. Thanks, Rick. My name is Manan Goel. I'm a principal product manager on the AWS analytics team. So I focus on some of our core technologies, SQL analytics with Redshift, LakeHouse, and some of the other services like Glue Data Catalog and Lake Formation. So what we're going to do over the next 30 minutes or so is talk about LakeHouse, SageMaker LakeHouse. We start out talking about what customers are telling us about their requirements as far as unified data management for analytics is concerned, how LakeHouse fits in. We'll dive a little bit deeper into some of the core capabilities that LakeHouse provides, and then we'll also do a short demo for you in terms of showing you how the LakeHouse experience looks like. So let's get started. Next slide, please. All right, so yeah, let's start with the introduction. So first of all, I'm sure everybody has heard about generative AI, how generative AI is really transforming the business experience across organizations. It's helping companies innovate in unique and differentiated ways. So if you look at what customers like you are being able to do with generative AI, build new experiences, these conversational experiences where your employees can benefit, your customers can benefit, also being able to boost productivity by being able to write code or generate content, if you will, deliver insights, rich and powerful insights, not just from structured data, but also from unstructured data. Things like being able to process documents, find insights in those documents, and then finally, boosting creativity. Helping you ideate better, faster, gain insights, from all of your data. So definitely, generative AI is pretty transformational. But there is more to generative AI that meets the eye. As Rick was saying, your data is a core foundation for building smarter, powerful, rich generative AI applications. So, if you look at generative AI applications, you essentially are basically calling a LLM that's doing something, but underneath the cover, there's a lot going on, in terms of data and what these applications are able to do with the data. So what is really important for building these, powerful generative AI applications is a strong data foundation. You need transactional databases to surface the experience from these generative AI applications. You need analytic systems like data warehouses, data lakes to find insights from that data and power these generative AI applications. You also need to build, have strong data integration capabilities. So you can move data from transactional systems into these analytic systems and surface it through the Gen AI applications. And then finally, governance is also very important because what generative AI is doing is really democratizing data across your entire organization. So more people in the company and even outside your company has access to this data. So having a secure, governed layer which provides the right access to the right people is really important for these generative AI applications. So as AWS, we've been actively working on many of these technologies for many, many years now. We've built a strong set of capabilities, purpose-built services to help you store, process, and analyze your data. So these include databases, analytic services like Redshift, like data lake services, like Aurora. These include governance services like Data Zone, for example, for AI ML services like SageMaker AI and things like that. And each of these services provide, their purpose built, they provide the best price performance. So, customers really like, what capabilities these provide. But what they're also telling us is these are building blocks for building an application. And it requires, these services require the builders, the customers using these services to be builders. And what they've been asking for is, unification or simplification across these services, both from a user experience level as well as a data management level. So the consumption of these services, the usage of these services to build end applications becomes a lot easier. So, The individual services has been good. Customers have been asking for unification. We talked about unification both at the user experience level, where you now have capabilities like SageMaker, Unified Studio. But let's talk about the underlying unification of data management as well, because that's what customers are also asking us for. And if you think about unification of data management, it's a really complex problem. Because what really happens with data is it comes from a variety of different places. It comes from databases, business applications, IoT devices, sensors, or things like that. And essentially what ends up happening is, you build data pipelines to extract this data, transform this data, land it in a data store for analytics. So you end up choosing, either data warehouses or data lakes. So that's kind of how this data is sort of processed for analytics. And essentially what happens is you end up picking purpose-built data stores to land this data. So in some cases, you're landing this data in a data lake, which gives you the ability to store both structured and unstructured data, have multiple engines, SQL engine or Spark engine go against this data. And in other cases, you're landing into a data warehouse, which gives you ACID compliance and ease of storage and analysis and things like that. But because of this disparate systems where you are landing this data, because of the workloads and all, what ends up happening is you end up creating a siloed environment where analytics becomes difficult. In the sense that you don't have interoperability across this data. Some of your unstructured data lives somewhere in a data lake. Structured data lives in data warehouse. So you have multiple copies of the data. You can't run the same kind of engine, SQL or Spark, against that data. Access control, you have to define access control in multiple places. That becomes complex, challenging. And at the end of the day, your infrastructure ends up being complex, slowing down innovation and helping you get to the value from the data faster. So essentially what customers are asking for is ability to bring these data warehouses and data lakes together, and that's where a LakeHouse comes in. So LakeHouse is basically a technical construct or implementation which really unifies the data warehouses and data lakes. And it gives you, the ability to interoperability of the data, so you can run multiple analytic engines, whether it's SQL or Spark or other engines on top of this data. It also gives you unification from a governance and access control perspective. So you define, security in one place, and it applies across, all the access points that you use against this data. So with this context, we are really excited to launch SageMaker LakeHouse. We launched SageMaker LakeHouse at re:Invent last year. And what this does is basically provides you with a unified, open, and secure platform solution to manage your data for analytics. The three key aspects of what we focused on as far as SageMaker LakeHouse is concerned is, first of all, unification. The second thing is openness, and the final thing is security. So unification in the sense that the LakeHouse brings the best of data lakes and data warehouses together. So you have single copy of the data. You don't have to worry about where data is stored, processed. You have unification across the storage layer and the analysis layer, if you will. It's open in the sense that everything in the LakeHouse is Apache Iceberg compatible. So what it means is that any of the AWS analytic engines, whether it's Redshift for SQL or EMR for big data processing, can go access this data. But even third-party engines, non-AWS engines like open source Spark or anything else, can also access this data and help you find insights in that data. And finally, it's secure and governed, because we give you a single layer of a technical metadata catalog and permissions management on top of this LakeHouse, where you can define your security and permissions in one place, and all of your front-end tools can access this data in a secure and a governed manner. So that's what SageMaker LakeHouse is, the problem it solves for the customers, the value it provides. Next, what I would like to do is dive a little bit deeper, look underneath the covers at the core elements of what the SageMaker LakeHouse is, and give you a little bit of flavor of what the technology behind the SageMaker Lakehouse is. So if you look at the SageMaker Lakehouse, there are 4 main components as far as the Lakehouse is concerned. There is a flexible storage layer, which gives you the ability to store data either in S3 or S3 tables or Redshift managed storage, which is a analytics optimized storage. So that's the first layer. The second layer is it gives you a unified technical catalog. Once you are able to store data in multiple places, you need a unified way to access this data, and that's where the Lakehouse gives you a unified technical catalog. The third thing it gives you is integrated permissions across all of these data sets. So you can define permissions in one place and access it. And finally, it gives you open access. So you can access that data using any Iceberg-compatible tools. So those are the 4 main components of the Lakehouse. So let's dive a little bit deeper and look into each of these components and see what value they provide you. So starting with the storage flexibility, as I was saying, there are 3 main ways where you can store data in a Lakehouse. So the first way is basically the general purpose Amazon S3. Many of you have been building data lakes using S3. So the first storage format you can use to store your Lakehouse data is in S3, which provides you flexibility to store both structured and unstructured data. It gives you the interoperability across the tools. It gives you also automatic optimizations like storage compaction and snapshot deletion and things like that. You get high performance with statistics on the data applied against the queries, and both AWS as well as non-AWS tools are able to access it. So you can continue to build your Lakehouse using S3. If you have existing S3-based data lakes, you can also bring them into Lakehouse. No migration involved. It's just a publishing of metadata, publishing of metadata into this. The second storage format that we also launched at re:Invent is this S3 tables, which is another abstraction layer on top of S3. So this is a purpose-built, these S3 tables are purpose-built table buckets to manage your data in more of a tabular format. It's Iceberg compatible, so it behaves like a transactional data lake, if you will. Gives you many of the things that S3 would give in terms of interoperability, open source compatibility. But the benefit with S3 tables is also because it's purpose-built for analytics. You get much better performance, you get much better throughput. So performance of S3 tables is up to 3x better, throughput is up to 10x better. So S3 does about 5,000 transactions per second. S3 tables can do 10x of that, about 50,000 transactions per second. So another basically you can use S3 if you want, you can use S3 tables. It further simplifies what you're able to do by storing data in S3. So some of the benefits that S3 tables automatically provides you is in terms of the consolidation of small objects, deletion of snapshots, things that we were talking about. And then the third and the final storage format that the data lake also provides you is the ability to store data in Redshift managed storage, which is basically an analytics optimized storage. So it has constructs like columnar storage, for example, compression, processing. So if you're running fast insert, update, deletes, you're accessing the data fairly quickly, you want lower SLAs, RMS might be a better way for you to store your data as far as the Lakehouse is concerned. RMS also provides a lot of machine learning optimized constructs like materialized views, for example, auto materialized views and all. So it gives you much better performance. And in terms of use cases, when should you use RMS versus S3 or S3 tables? As I was saying, if you have a lot of insert, update, deletes happening, concurrently in your data Lakehouse, or if you want to run low latency, high concurrency workloads like dashboards and all, you will get much better performance with Redshift managed storage. What we have seen in internal benchmarks is up to 7x better throughput. When you're running Spark workloads, for example, quick, short queries, quick writes, up to 50% better performance with RMS basically. So the first layer of the Lakehouse, storage, you have 3 different options: S3, S3 tables, RMS. You can pick and choose based on your use case, whichever you want to use. And again, there are no one-way doors here. You can start with whatever you want and move to a different format if you want to do that. All right, so once we have given you, these multiple way to store your data, the next thing you need is a unified catalog against this data, so you can visualize all of these data together and you can analyze it easily. So that's what, what we did there is we took a technical catalog, which was the glue data catalog, and extended it to add, multi-level hierarchies into it. So all of this data can seamlessly be surfaced in one single place, and you can access and analyze it. So, the technical catalog on top of LakeHouse, which is the glue data catalog, now has, multiple catalog constructs. There are two types of catalog constructs you'll see there. There's a managed catalog, where if you are creating new data, you'll create a managed catalog, and all the catalog is basically a container or a pointer to your underlying data. So if you're creating new data, you'll create a new managed catalog. It could be based on RMS, could be based on S3. If you are bringing in existing data into the LakeHouse, let's say if you have a Redshift data warehouse and you want to surface that data into the LakeHouse, then you create a federated catalog basically. And again, for any of these things, there is no actual data movement. There is just the metadata which is being surfaced there. And as a result of that metadata being surfaced, all of your data is becoming Iceberg compatible. So you can access it through the engines you've been using like Redshift, but you can also access it with third-party engines and Spark and things like that. So these are basically like from a catalog perspective, managed catalog, you're creating it against RMS or S3. Federated catalog, meaning like your data already exists. You can bring in like existing Redshift data warehouses, S3 tables, or you can even federate data. So if you have data in BigQuery, let's say, you can bring that into a federated catalog. And there's a comprehensive roadmap here where in the future you'll see us adding more and more capabilities here. All right, and as part of this, what we are also doing is like sort of giving you a multi-catalog hierarchy. So if you look at this example, Carlos is going to do a demo. He'll show us like what these multiple catalogs will look like. But like if you're mapping a Redshift data warehouse into this catalog, this is sort of how it would map into a catalog, subcatalogs, and then you have tables underneath it, and you'll have these multiple catalogs within your catalog hierarchy. One could be for Redshift, one could be for S3 tables, and you can access data across all of those basically. All right, so two things we have talked about so far: storage in the LakeHouse. We talked about the catalog on the LakeHouse. The third thing is integrated access. How do I give permissions to the users to access this data? So the LakeHouse supports various constructs, fine-grained access control. So defining permissions, allow, deny permissions at the table level. You can also do it at the row level, column level. So you have row level security, column level security. Combine them to get like security for cells specifically. For third-party sources, we also support things like role-based access control or tag-based access control. So those are also supported. And then to share data, there are things like zero-copy sharing to share data across, across your teams, outside your organization, things like that. Couple of examples of what like the column level security would look like. In the LakeHouse, using lake formation, you can go in and define who has access to which columns. You can also define who has access to which rows. So you can say people in US can only see US data, Europe can only see Europe data, and then you can combine them together to also get like cell level security. And then on the tag-based access control side, basically what you do is like you can tag certain data as, let's say you have some certain tables, you can say they are tagged as PII data, personally identifiable data, and then give that PII access to specific users. So you can use that construct as well to simplify access for different users across the organization. And finally, in terms of sharing, data sharing across, using LakeHouse, we support a number of constructs. You can have a hub and spoke model, where you have a centralized way of managing the data as hub, and your consumers can be the spokes who can access that data. Or you can do peer-to-peer data sharing using data mesh architectures. We also support cross-account, cross-region, so you can share data not only within your organization, but outside your organization as well. All right, so 3 things so far: storage of data, catalog, access. The final thing is, what do you do with this data? So open access. And what we are doing there, what we did there was basically made everything Apache Iceberg compatible. So the catalog is basically supporting Iceberg REST catalog APIs. What it means that any tool, AWS tool like Redshift or EMR, Athena, or third-party tools, open source Spark or other tools can access that data. Single copy of the data can be accessed by any of the tools, and you can find insights using that data. And just a little bit about the Iceberg REST catalog APIs. We are basically using open standards here. This is managed by our open source community. So what we are implementing is basically, which is something which is totally, vendor agnostic. So tomorrow, if you come in and decide, I want to use a different catalog, you're completely free to do that, because everything is based on, open standards. So that's kind of what we have, And finally, we also simplified zero ETL integration, getting data into the LakeHouse easy. So we have zero ETL integrations now across 4 databases, 8 business applications like SAP, Salesforce, and even federated query capabilities, where you can leave data in place, access it. Like if you have, let's say, BigQuery, you can access that data through the LakeHouse as well. So those are the 4 key things as far as the LakeHouse is concerned. As far as the technology is concerned, storage across different formats, the catalog, unified catalog, integrated permissions, and access using Apache Iceberg API. So with that, what I'm going to do is turn it over to Carlos to walk us through a couple of use cases and demo of a few things.
Thank you. So thank you. My name is Carlos. I'm working as a data specialist. Been working mostly with Iceberg-related use case and customers these days. So I'm very happy to talk about LakeHouse. So a few things that it's important just to make sure that we bring everything together. A few things in terms of LakeHouse. So the idea is that you have unified catalog, as Manan is saying. And that means that if you have an existing data warehouse, you can bring that into the LakeHouse catalog. It doesn't really matter if it's like a provisioned cluster or a serverless one. You can easily go and just make sure that you are registering that existing Redshift into your LakeHouse catalog. This is something that you'll do only once, pretty much. And once you do that, you get like a request, like saying, I want to register. Then you go to Lake Formation. You accept, you basically then define the permissions, and after that, essentially, you are exposing your catalog to your Redshift tables to your users. I'm going to show that in a second, so I will just move on, which means basically that after that point, you can just query the data using any engine or basically using Spark. And the other use case is now that, for example, you are working with your data. Doesn't matter what's the source, if it's like an S3 table or a Redshift table. You can decide based on like the different use case or performance requirements to basically store, like you do a ETL job, and then you want to store that as a new table. What you can do now is basically you store it as a new Iceberg table, or for some use case, you can even store it as a managed Redshift storage table, meaning that you have Spark and you just write the data as either Iceberg table or normal CSV table or the Redshift managed storage table. And kind of the benefits here is that then you can leverage advanced functionality from Redshift like materialized views, etc. It's also pretty simple. Just for the sake of time, I'm going to try to move into the demo. So this is a little bit risky because networking today, Wi-Fi, is a little bit dodgy. So I had to run it in the morning, and I will not, 1 second, click into too many places. Can we switch? OK. Can we switch screens? Amazing. So In terms of the demo, what I'm going to show you quickly is that your perspective from the Unified Studio. And the idea is that, again, you create the catalog. The catalog is going to be Iceberg REST API compliant. And then you can bring like your existing Redshift clusters as like a federated catalog. And that's what you're going to see here when I'm going to this tab, for example. This is my technical catalog. You see like LakeHouse here. And for example, let's imagine I have like a business unit or a department that runs everything using a data lake approach. They are like the customer inside team. So basically, they just have S3 tables. Some tables are in CSV, other tables are in Iceberg. But I really don't care when I'm trying to build like new products, new machine learning models, or GenAI applications. I really don't care anymore. And OK, that's like the issues with with the live demos. So just bear with me for a second while it's loading. And basically, in the other part of the technical catalog, you could see there was like basically a tab with the Redshift tables. OK. Let me just preload. Let me go back to this one. OK. And here, in the bottom, you can see these are basically the tables that I had in an existing Redshift cluster. Again, this is something that your admin team or operations team will mount once, and that's it. And now, like as a data user, I can just go and basically start querying these tables. And for me, it's transparent, because if you look into here, I can just go and say I want to query with Athena, or with Redshift, or even with a Jupyter notebook. And the same will apply for these other tables that I have here. And now to show a little bit of code. OK, let me see if I can open it. Just bear with me for another second. Otherwise, I have backup screenshots. Cool, it's loading. I did run the cells like a couple of minutes ago, but essentially what I'm going to show is pretty much the same idea. Now as like a data engineer or a ML engineer, I go here. You can see like my naming convention is not great, but please ignore that part. And then the idea is that I go to my notebook. So this is vanilla open source Spark code. Here I'm just basically setting the configurations, typical Iceberg configurations to load like the Iceberg client library so that Spark can speak Iceberg. And it's very like normal. There is nothing here special. And then if I start scrolling down, here I'm showing like the example, querying like Iceberg tables in my Goel catalog, which is REST compliant, meaning that Spark will do first a call to the REST catalog to see, for example, I want to find out the data in this table, and the REST catalog will tell you, OK, you need to open file A, B, and C. Essentially, that's like the role of the REST catalog. And you can see I can list my tables, and these are basically open APIs that you can see in either the public documentation of the REST catalog or even in our documentation. And then I can query the table, and I get the results. So it's vanilla Spark code. There is no like black magic here. And then I'm going to do the same, but now to query like a Redshift managed storage. In this case, it's like a Redshift that I did add as a federated catalog. And it's pretty much, again, vanilla Spark code. So I'm going to list. Let me maybe zoom for the folks in the back. Hopefully, it's fine. Can you read it? OK, thank you so much. And basically, now I'm listing the tables. These, again, are Redshift tables, but we don't really care as a data user. For me, just normal tables, which I'm accessing via SQL. And then I can, again, query those tables to get the information. And finally, now that I have access to these different storage layouts and different tables in different solutions, like a LakeHouse and a Redshift, what I can do is basically write my ETL jobs. And here I'm doing like a very simple ETL job where I'm joining a table from S3 with a table in Redshift. And then I'm basically doing the join and then inserting as a new table. And again, as Manan was explaining to you, you can put this new table anywhere that you like, depending on your use case. Again, just a vanilla S3 table, or the new S3 tables that we have announced, or like an Iceberg table in S3, or a RMS table, basically. So it's really up to you. The code is pretty much the same. You are just changing the name of the catalog and the tables that you want to use. And this is basically using like our services, but let's say you want to use actually like a different tool, like let's say DuckDB, which is quite popular, or PyIceberg, which is a vanilla Iceberg client. It's pretty much the same. The only difference is that here, like our engines are using basically simple configurations. What you need to do with the open source is just get basically the REST endpoint from the Iceberg catalog that you can quickly find in our documentation. And it's pretty much the same way. It works the same way. It's the configuration the other open source libraries are expecting. Nothing changes. You provide that configuration, and you access these tables exactly the same way. Okay? Hopefully this was interesting. So this is an error, just to make sure this is like a real demo, but it's just saying that I've created the table before. And yeah, you can access the new table that you have pre-created. And then also pointing out basically permissions. I'm not sure if I'm going to be able to navigate. Okay, basically this is the technical catalog where you publish the table, then you can move this table into the business catalog, and you enable basically like proper data governance. Like another team can go find that table in the business catalog and ask for access, and you as a producer, you will tell, okay, you can have full table access from the SageMaker Unified Studio, or tell them you will have just filtered access. Basically, you can access all the columns except the ones that contain PII, which probably I won't be able to show because we are running out of time. Hopefully this was interesting to you. We have this as a workshop, so if you have interested in looking into these code examples, I see some familiar faces. We did that yesterday, and we are going to do this in some virtual events, in some locations as well in person. Otherwise, just reach out to your account teams, and we are happy to engage with you, share these code examples, help you with the configuration, setup, anything. Okay? Thank you so much.